Okay, Ian Zepp here. This is G4 Week 3 MVP demo video. This is for the Legacy Lens project, which is intake of a legacy COBOL system to a RAG database and then processing it with an LLM. So here is the user interface. There are some additions that aren't included in this because Railway is presently having degraded performance and they have disabled the deployment of new updates. So until that gets resolved, I can't push some of my newer code in, so we're stuck with what we have. Let me do a quick suggestion here. So the way that this works is we ask a question. It goes first to the RAG database, which is we're using Pinecone, I believe is, well, I don't believe, I know, is the underlying vector database, and then it returns chunks that it believes match the particular query, and then all of those chunks are then delivered to the LLM, which in this case we're using 4O Mini. And then 4O Mini processes those and returns to us a summary that supposedly answers our question. So for the final submission, I will be testing if this response actually makes sense or not using an Opus 4.6 against the chunks and the response that the LLM is sending back. But we don't have that verification step in place just yet. What we do have is we do have L1 and L2 caching, and we have streaming enabled. Streaming is pretty straightforward. If I just run this again, no, let me turn off the caching. If I run this again, what we'll see is the results are coming back in. Now that's nice from a usability perspective. It does take a little bit longer. We are capturing down here on the bottom some basic statistics. So the return time for the RAG is currently cached. That's the L1 cache. I'll explain that in just a second. The LLM TTFT is the time to first token. So how long does it take the LLM to give us its initial response tokens? And then the total LLM response is the 8 seconds that we see here, which is significantly slower. A lot of that has to do with how long the response is. The other half of that has to do with the model that we're using. So this particular model is not super fast at giving data back. L1 cache, and one of the optimizations that was made is there's a library. I've included a library of 209 suggested questions, which were distilled out of the actual underlying code base itself. And with those suggested questions, because we know what the question is, we can pre-calculate what the RAG chunks will be. So that has been done. They're cached inside the server as the server is getting deployed. And as a result, if a user hits one of these questions, it doesn't need to go to the vector database and get the chunks. It already knows what the chunks are because it knows what the question is. L2 cache is what caches the LLM's response in memory. And that's particular to the LLM itself. Different LLMs will give you back different text. So we've included that, but we've also included a way for the user to turn that off if they want to get a fresh stream. Looking over the MVP requirements, ingest a legacy code base. Obviously, that's done. We did AWS card demo. This is 40,000 lines of code, of which probably 25 to 30,000 are actual COBOL itself. And again, if we look here in any random chunk, you can see this is the COBOL program structure. We chunked the code files. We used paragraph level chunking instead of fixed level chunking because COBOL maps well to paragraph level chunking. Generated all the embeddings. We did that in a number of different ways. So I have, and I'll go over this more in the final video submission, but done some fairly extensive benchmarking of a whole slew of different index types. And again, I'm not going to get into it right here, but that has been taken care of for the MVP. Semantic search, that was done. You saw that. Natural language query on the web, we have that. Relevant code snippets, you saw that. And basic answer generation, you saw that as well. And deployed and publicly accessible. So that's this website right here. So that is my quick MVP demo. Thanks for watching.